to the session.
Thank you, Prasanna ji.
You are joining from Murshidabad?
Yes. I stay at West Bengal itself. So basically, I'm from Karnataka. So
very nice. How is the situation there? Too much of flood there, or is it okay?
so this Murshidabad is approximately 270 kilometers away from Kolkata.
Mhm.
So we are actually closer to Bangladesh rather than any coastal area.
కలిసాం సార్.
Okay, so no flooding in your area, no big river in your proximity. Right. So we are still about 4-5 minutes away from the start of the session. More students and faculty are joining, so we will give them some more time. And at around 10:15 or so, we will try and commence seeing the number of people that have joined. Sometimes it gets a few more minutes delayed, so I hope that's okay with you.
Yeah, definitely. Fine with me. So hope my audio is clear. If it is not clear, let me know so that I can use my headphones.
The audio is okay.
Okay, Chetan sir, I'll take a leave now.
Sure, sir.
Prasanna
Bye.
sir will engage the session. Okay, he'll be our
Yes,
host
sir.
for the program.
Thank you so much, Professor
Thank you,
Shian.
Prasanna sir.
See you, Shreya. You have a great day there.
Yeah, thank you.
Right. Good morning, ladies and gentlemen. Good morning, faculty members and students. Uh, it's around time, 10:16 now, as per my machine. It's a nice, bright, cool, breezy, sunny morning on Bangalore. I'm not sure about Murshidabad, from where Dr. Chetan is joining us. It's indeed my privilege today to welcome Dr. Chetan on behalf of our director, Dr. Venkatesh BR, and the faculty members and students as well. And I also welcome everybody who has joined the session. A few more people may be joining now in next few minutes. Typically, we believe in Indian stretchable time, so maybe we'll have to wait for another few minutes before we actually hand over the session to Dr. Chetan. In the meantime, I would like to let you guys know about the credentials of Dr. Chetan, doctorate in finance and so on. So let me give you a brief overview. So he's presently working as a associate professor of finance at NDI Murshidabad, Management Development Institute Murshidabad, town north of Kolkata, bordering Bangladesh. He hails from Karnataka. He did his MBA from Karnataka University in Dharwad, and he has a doctorate in finance from Jain University, Bengaluru. He worked as Associate Professor of Finance at Kirloskar Institute of Advanced Management Studies for 6 years. And he also has some corporate experience where he has worked as dealer for equities and F&O at Kotak Securities before he joined academia, that is, before taking up the academic work. So his broad research interests include corporate finance, equity valuation, and futures and options. All these words, all these terms are quite familiar to our MBA students, I'm sure. He accomplished various certification courses of NSE, National Stock Exchange, as well as Bombay Stock Exchange. So Dr. Chetan brings to us today a very interesting topic, so to say, using Excel sheet for financial work. I'm not a finance guy, but I'm a strategy guy. But anyway, I have some background knowledge of it, so I'll be very happy to get educated today from somebody who has experience in industry as well as done some academic work in this field. And we are looking forward to benefiting from this. Dr. Chetan, welcome once again. And I would now hand over to Dr. Chetan. Some of the hygiene factors before that. Everybody, all the audience except me and Dr. Chetan are requested to keep themselves in mute. Note down your questions and queries that you might have. Towards the end of the session, after about 45 minutes or so, we will open the house for question answers. That is the time you can take out your questions, and then Dr. Chetan will be happy to answer those questions in the last about 15-20 minutes that we will have. Request everybody else to even mute your videos as well. So not only audio, but video as well. That will help in preserving bandwidth, as well as some disturbances can be avoided. So over to you, Dr. Chetan, once again, welcome. And you may now like to start, please. Puneet, would you like to please switch off your video? Puneet? Yeah, thanks.
Thank you, Prasannaji, for your kind words and introducing me to the audience. Yes, we will start off with the presentation, and I'll also be using Excel sheet here and there to explain, because it's an application oriented, and just in 1 hour, how much ever it is possible from my end with respect to financial mathematics, I would like to cover here. Thank you, Prasannaji. I'll be using my PPT now. So I'll be sharing PPT now.
Yes.
I'm used to WebEx and Zoom, and this is something which is new for me. So let me just check. Oh, my presentation is visible now?
Yes, it is visible.
Thank you so much. The Excel sheet is also visible, right?
Yes.
I'll be just navigating to with PPT as well as Excel sheet. So thank you so much. So financial mathematics is actually something which is quite very extensive topic that is to be covered. So, however, I'll be in this particular session, I'll be covering very basics of financial mathematics, and I'll be using Excel sheet for demonstration for hands-on experience also. Uh, so first we'll do what we'll do is we will go and see all the tables, how to construct them in the Excel sheet, and how to interpret them. Quickly we'll do that in fact. So this is Excel sheet. I'm there on Excel sheet. So you know that these tables are very quite common to all of you. These are quite common to all of you in fact. So you have seen present value tables, future value tables. Okay. So when I was doing my MBA, that time when professor distributed this particular sheets of paper, I was wondering how this particular values have come. Okay, so I'll just take some time and I'll make you understand how is it, how is this. So let's say I'm actually going with present value. So present value in the sense that you know what is the formula for that. So 1 divided by 1 plus r whole raised to n. So I'm just putting that 1 divided by 1 plus my r is 1% here. Okay, so I'll just close the brackets and then I put just the epsilon raised to 1, and I just fix up this with some dollar signs which has been required for doing this calculation. So I'm just restricting this to 3 decimal places. Normally, if you take up any of the schedule of time value of money tables, you can see that impact. So this has been restricted to 3 decimal places, is it not? So now I'm just doing it for all the percentage terms in fact. So this is what is my present value table. Okay, this is how it looks like. Okay, this is the start of financial mathematics in fact. Okay, so let us interpret how this particular, what is this particular value is all about. For example, I go with this. Assume that this is the cell I would like to interpret. So how to interpret this 0.386? How to interpret this 0.386 is if I'm going to receive 1 rupee after 1 year, sorry, after 10 years, because this is a 10 years table it is, and you can see it is 10%. Okay. So if I receive 1 rupee after 10 years, okay, so down the line, after 10 years, if I receive 1 rupee, how much that particular 1 rupee is worth in present value terms at the rate of 10% is 39 paise. Approximately it is 39 paise. That is what is the value of 1 rupee. Okay. Similarly, if I ask you how to interpret this particular value, okay, so how to interpret this is after 7 years, from here after 7 years, if I receive 1 rupee, okay, how much is worth now? Today, that particular 1 rupee is worth how much? If I ask a question, so at the rate of 6%, it is worth approximately 67 paise. Okay, so that's how we should be interpreting this particular table, and I guess everybody out here are quite well versed with this particular example, because this is how we relate this in the finance classes. Okay, that you have been already seen this. Okay, so here we have used what is it I have done is I have used direct formula here. Direct formula in the sense that formula, what is it we have learnt in the class, 1 divided by 1 plus r whole raised to n. That is what is the equation, we have used it here. Okay, so what if I want to use it for, which is something which is inbuilt in Excel itself, how to do that? Okay, so I just copy paste it in the next sheet. I'm going to delete this. I'm going to delete this. So I just go here and put present value. It is a direct function which is available on Excel. Okay, present value, I hit tab and then I select this 1%, and next is n per. Sorry, I'll just open this formula bar. Hope this is visible also. Rate, n per, PMT, FE, type. Hope this is visible. The function argument that this particular window is visible. Anybody can just unmute and tell me whether it is visible or not. Otherwise,
Yes,
It's visible.
yeah, thank you so much. Rate. So how much is the rate? It is 1%. It is. And next tab is n per. N per is n. We normally call it as number of years, right? So number of years column I'll be selecting, that is 1. I'll be selecting it here, 1. So what is PMT? Is payment. It is. It is actually useful if you're going for annuity factor. If you're going for annuity calculation, payment is useful. So otherwise, we are actually going to skip this. We should not be filling up PMT with anything else. So future value, how much is future value it is asking. So since we are interested in 1 rupee, I am just putting it as -1. Okay, so please understand, if you are not going to put -1 here, the answer what you get is will be negative. That is why just put it minus. Don't worry much about it. Okay, so minus, you put whatever the value you are going to put it, put just minus. Okay, so if you want to get the value in the positive, you have to put it minus here. That is what is the thing here. So type, it is a logical value. You can skip this. So I just press OK now. So you can get you will get the same answer. In fact. So this is how you have to be playing around with the numbers in the Excel sheet for that part. So I'm fixing up with dollar value signs here as usual, and I press enter. So I just show you how is it can be done for all of the table. So this is how we have constructed. This is normally called as I'll just put it as A3 table, or it is also called as table 3. It is table 3 or table C. In some of the books, it has been referred to as a table C. Okay? So this is how this particular thing has come. Okay, so this is A3 table, and we have constructed using this PV direct function available on the Excel platform. Okay, so that is what it is. So the interpretation remains the same. Whatever we have interpreted in the previous sheet, the interpretation for this particular thing is also remains the same. Okay, so we will go to the next sheet now. We'll go to the next sheet. I'll just copy paste this to the next sheet. Okay, so I'll be copy pasting this in the next sheet. I'll delete this because we are going to the present value interest factor of an annuity, that is present value interest factor of an annuity. This is also called as a table A3. This is also called as table A4. Sorry, table A4, which is also called as a table D. In some of the books, it is also referred to as a table D. Okay, so is equal to I'll go to direct function of Excel, that is PV function. So hit tab. So next is 1. So this is rate. It is asking for rate. It is asking for rate. So I've just put it. The rate is 1%. So N per is 1 year. So PMT, it is PMT now. We have to be considering this PMT, which is -1. Okay. So why is it we are actually going to be using PMT here? Is it's an annuity table it is, and because of which we'll be using the PMT. So if you are going to input something in PMT, you should not be putting anything in future value here. So type is at the beginning of the year or at the end of the year. So by default, we are all the time value of money tables are going to be at the end of the year. So if you just if you ignore this also, automatically it is going to consider that these are the end of the year payments. Okay? So I'll just click OK now. So we got this answer. Okay. So I'll just put dollar signs as usual to fix up the values so that it will be easier for us to construct the table. Okay, so we are getting the results already. So this is our A4 table. In other words, it's a table D. This is a table D. So we'll see how to interpret this particular table D. So I just take one particular value and we will interpret. You know that this is the present value interest factor of an annuity. Of a rupee it is because we have put -1. If you remember in the formula, you can just see in the formula we have put -1. So -1 in the sense that we are interested in 1 rupee. So if you want to extrapolate it to, let's say, different sums of monies, let's say 50,000, 1 lakh, you can just multiply this with the 1 lakh rupees or 2 lakh rupees, 50,000 or 500, whatever it is going to give you the right answer. So we'll see how to interpret this particular value here. So 6.71. How to interpret this is if you are going to receive 1 rupee at the end of each year for the next 10 years, how much that particular value is worth in t is equal to 0 terms. So t is equal to 0 is termed as today. Right now is termed as what? Mathematically, how to express this right now or today is t is equal to 0. So t is equal to 0 means at today, that is present. At present, how much that particular value worth? Okay. So rupee means what? 1 rupee. If you are going to receive, let's say I am going to give you. If I say to any of the student to you that I'll be giving you 1 rupee at the end of each year for the next 10 years. So if I give you 1 rupee at the end of each year for the next 10 years, how much rupees I would have given it to you at the end of 10 years? It is, of course, it is easy, 10 rupees. Okay, so 10 rupees I would have given you at the end of each year for the next 10 years. So if I ask you how much that particular 10 rupees worth, which I will be giving you in different time horizons, this 1 rupee which I'll be giving you is in different time horizons. So how much is the value of that 10 rupees which you'll be receiving in different time horizons at t is equal to 0? That is today how much it is worth at the rate of 8%. If I ask you a question, what is the answer? That the answer is 6 rupees and 70 paise, approximately 70 paise. That is what is the answer you should be giving it to me by seeing this particular table. Okay. Similarly, if I go to let's say this particular what is it value which has been highlighted by me now. So 11.652 is the value. So you can see what is the corresponding value that is 16 and 4% it is. So 16 is yes obviously, and 4 is a percentage it is. Okay, so if I give you 1 rupee at the end of each year for the next 16 years, how much it is worth at t is equal to 0? If I ask you a question, what should be your answer? That is 11.65, 11 rupees and 65 paise approximately, and don't forget it is at the rate of 4% it is. Okay, so that is how we should be interpreting this particular table values. That in fact, it's just I have given you briefing in this particular financial mathematics class. Okay, let's move on to the next thing. So if I ask you a question, how to do this? Let's say how to do this. If I'm going to give you 1 rupee, not at the end of each year, but at the beginning of each year. Okay, so how this particular table looks like. So what I should be doing now is, for this particular table, I just put, I'll just go to this fx function. You can see here type is there. Now I have left it blank in the previous example. So I put it as a 1. So payment at the end of the year is 0. And if I omit also, it is going to by default take it as 0. So now I'm just putting it as 1, which means all my interest, my accruals are going to be at the beginning of the year. Okay. So I'll just hit OK now. Okay. So now I'll just make this particular table looks like. So yes, now everything else has been got changed. You can see everything else has been got changed. Okay. So this is how we should be doing it. Okay. So if it is at the end of the year or at the beginning of the year, this is how we should be doing in the formula. So only thing is we should be changing in the schedule. Instead of 0, we are putting it 1. So if we are not putting any 0 there, by default, it is going to take it as 0 itself. That is the basic functionality of Excel for that matter. Hope everybody has understood this. I am moving on to the next example now. So I'll just take this up example. Take this random example. So assume that this is 1 and 1, 2, 3, 4, and 5 years. Okay, so these are your cash inflows. These are your cash inflows in the sense that these are the cash future inflows. These are the cash future inflows. I'm using a rand between function to just put some random values here for my this thing. Yeah, these are the cash inflows. Assume that these are the cash inflows you'll be getting at the end of each year for the next 5 years. Okay, so I'll just fix up this particular value now. So I just copy this, paste values. Yeah, so I have fixed up this particular value so that these values will not change now onwards. So assume that present value at the rate of it is given as you can take any value for that matter. Since it's an Excel sheet, I have the luxury of choosing, let's say, 13.256%. Okay. Fine. So I'll be calculating now the present value of these. I should be doing it for 1 rupee first of all. Okay, so 1 plus 13.256. So I should be putting here 13 is there already, is it not? So I should be putting 0.13256. So this is 13.256 it is. Hope everybody understood this. Is brackets closed, epsilon raised to 1. Okay, so if I press enter, so I got this particular value. How to interpret this particular value here is 0.8883. This is the value we got it. Okay, so this is your table A3. This is your table A3 it is, or this is table C. In other words, in some of the textbooks, it is given as table C it is. So hope you have understood what I am trying to say. Okay, so I'll just total it up now. So how to total it? This is cash inflows multiplied by the present value factors. If I just press enter, I keep getting the answers now. So what I'll do is I'll sum it up now. So I'll sum it up now. So I got this particular value. So how much is this? We will see now. How much is this? We will see now. Okay. So 33 lakhs 83,000 it is. So whatever the cash inflows I'm going to get in the next 5 years. Okay. So this is actually going to be, let's say you have installed a machine and it is the cash flows you are actually going to get out of that particular machinery is let's say 7 lakhs 58,791 and so on for the next 5 years. These are the cash inflows you are going to get out of the for that particular project. Okay. So if I add up all those 5 years cash inflows, how much I get is approximately 34 lakhs. I get approximately 34 lakhs. Okay. If I want to know how much is the present value of these future cash inflows at the rate of 13.256, assume that 13.256 is your cost of capital. Okay, so how to do this in Excel is we have just cross multiplied. These are the things we have cross multiplied, and we have summed it up, and we got it as 23 lakhs and 38,000 approximately is the total present value of all the future cash inflows which will be generating out of this particular project which we have installed. That project may be anything else for that matter. I am just leaving it to your for your creativity to just to have. So this is how we should be doing it, is it not? So let's say what if my cash inflows are actually going to be same? So I will take an example wherein the cash inflows are going to be same. So instead I'll just make it as 10,000 each. So 10,000 each is my cash inflows. So 10,000 if I'm going to get for the next 5 years, at the end of each year, if I'm get 10,000 from this particular project, so total project which will be total cash inflows from this particular project will be 50,000, but in varying time periods I'll be getting this 50,000, not in one particular one go. Okay, so if I have calculated this, okay, what is the present value of 50,000 if I ask a question? So then you will easily say that 35,000 is the total value of 50,000 at the rate of 13.256 as the discount rate or the interest payment. Okay, so if I want to do it using Excel sheet, how should I be doing it? Direct formula, you know it. I already did this. So this is PV. The rate is 13.256. I'll put 13.256. Don't forget to put percentage here. Okay, so I'll just put 13.256. And next is N per is how many years it is? 5 years it is it not? So 5 years is that one. And payment is how much here? The 10,000 rupees is the constant cash flow, which is an annuity. So I have to put it here 10,000 in minus terms here. And then I should be not be putting anything for future value because I should be putting PMT or future value, not both. So what is the type here at the end of the year? I am just putting it as 0. 0 means Excel automatically understand this 10,000 at the end of each year. That is what Excel is going to understand if I'm going to put 0 here. So I press OK here now. So you can see 34,953. The same answer we got it. Okay, the same answer we got it with respect to whatever we have got it here. Okay, display these things are actually matching now. So these things are actually matching now. So, okay, so this is how we should be doing. Supposing if you have got let's say ready sheet with you, how to do that particular calculation? If you ask me that, so I'll just go to what is this 13.2 is there? No? So instead of 13.256, assume that it is 5 years, and let's say 13%. This is the criteria. What I should be doing instead of doing this Excel calculation, if a sheet of paper is ready with me, then I go to this sheet number where we already done 5 years and 13%. So 5 years and 13%. This is the value for me, is it not? So 5 years, 3.97, okay, 13% and 5 years. I pick this particular value. Then I multiply this with 10,000. Just a second. So I'll just go to this and 13% and 5 years. Okay, so this is what is the value. I just press enter. So I got this particular value. And try to understand, this is not 13.256, this is 13%. It is. That is what you have to be understanding. Okay. So how is that we got this particular values? I have put here the formula referencing. You can just go through it. I can share this particular sheet of Excel sheet once I'll be done with my lecture. So with Dr. Prasanna Ji, I can share this particular sheet of Excel sheet so that it is quite clear for you guys. Okay. So hope this has been clear with everybody else with respect to calculation what we did. So this is all with respect to present value interest factor of an annuity it is. Okay. So next what I'll do is, after understanding this, we will go to the next sheet, which is going to be what? Yes, you are guessing is correct. So this is again 1%. I'll just put for 1%, 2%, whatever we did it for present value, we go for the future value for the calculation of the future values now. So I just put 1, 2 here, 1, 2, and I can select it easily. I'm doing it quite fast because I'm using Excel sheet. Otherwise, in a pen and paper, if I want to do this calculation, this would have taken much of my time and quite difficult to do it in the classroom using a whiteboard or blackboard, whatever it is. So I have a luxury of Excel sheet. So I am explaining with ease. Okay. So how to do this? If I want to calculate the present future value of a rupee, how to do this? You know that the present value multiplied by 1 plus r, 1 plus r, 1 plus r raised to what? Raised to it is raised to number of years it is. Now, instead of year, the one putting 1, I'll just select this particular cell. That is what I did here. So it is giving me in percentage terms. I'll just go here and change to number. Okay. So the moment I change it to number, automatically it changes now. You can see here. So what I'll do is I'll fix up this particular cell with the dollar signs. So I'll be fixing up this particular this with the dollar sign, and then I go further. So I got the answer. Okay. So this is the future value interest factor. It is. Okay. So this is what is a table which we got it using future value. How to interpret this? How to interpret this particular value? Quickly we go through this. I'll just highlight one particular cell randomly. 1.838. How to interpret this value is, if I deposit 1 rupee at t is equal to 0, that is today, if I invest 1 rupee at t0, okay, at the rate of 7%, okay, for the next 9 years, okay, 1 rupee will become 1.838 rupees. That is 1 rupees and 84 paise approximately, okay, after 9 years. Okay, if I am going to invest now at the rate of 7%. Okay, you can ask me, sir, the rate of interest is quite less, not even 5%. So you can just you can go for 5% and see. Okay, State Bank, even you can go for 4% and you can check for the next 10 years. So 1 rupee, if you are going to invest today at the rate of 4%, after 10 years, we are going to be receiving 1.4. That is 1 rupees and 42 paise will be receiving from, let's say, State Bank of India. If the rate of interest is 4%. So even not even it is 50%. It is actually less than 50%. It is. The return will be total return. If you just see for the next 10 years, it is going to be less than 50%. In the previous days, we used to know that we used to hear that in 5 years, our money used to be get doubled. Is it not? So when our parents used to deposit their sums of monies in the bank account, it used to be get doubled in 5 years if it's a fixed deposit. So gone are those days, because now we have seen in case of Japan and other European countries, even that particular interest rates have actually come up in negative territories also. So that particular examples are also evident for us. Okay, so let us not in fact expect much from this. So we have seen how to use using this particular direct formula equation using direct formula which you have normally used in the class. But how to use the Excel function, we will be discussing it now. Okay, so I'll just go to the next sheet. I'll paste this and I'll delete as usual. I'll be deleting this. So we have got like PV, we have got FV direct function. We have got it. So I press on this FX. So rate. So how much is the rate? We take it as 1%. N per is 1 year. How much is PMT? So since it's in a single payment, we should be ignoring this PMT. How much is the present value? So present value of 1 rupee you are discussing. So we should be putting -1, not just 1. It is -1 type. we can just ignore this and you press OK, you will get this particular answer. So I'll be fixing up the value with the dollar sign. So I'll be fixing up now. So if I fix it up, you can see how this particular values have actually come up. Okay. So these are the values. This is how we should be doing using the direct values, direct Excel function. See, if you really see sheet 5 and sheet 6, there is no difference with respect to the values which we have got it. Only thing is it's the direct formula we have used, which is available in the Excel sheet. Okay. So, however, the interpretation remains the same. The interpretation remains the same. Okay. So now we are going to the next sheet, and we will be discussing now future value interest factor of an annuity. Okay. So I'll just go and select this, and then I paste it here, and as usual I delete this, and we are discussing now the A2 table. It is also called as A2 table, which is also called as your table B, or it is also called as future value interest factor. So this particular table what we are discussing is table B. Yes, table B, future value interest factor of an annuity. It is future value FVIFA. It is FVIFA. It is A2. It is also called as B table. So how to do this is using the same FV function. It is. So I'll just put this FV function and put for fx. So rate is how much? The rate is 1%. N per is 1. And the moment it is annuity, we have to be very careful here. Instead of PV, we have to be putting PMT. PMT stands for payment. How much is that? It is 1 rupee. It is. So we have to be keeping nothing here in the PV here. And next is type. We are choosing at the beginning of each year. Sorry, at the end of each year. So I have put it here 0 and I press enter. So I got this value. Again, I'll as usual I'll put dollar signs. Okay. So here instead of dollar I put 4. That is why Excel is prompting me there is something wrong. Okay. So now I'll drag this with this particular handle. Yeah. So I got this particular table now. This is of the future value interest factor of an annuity. So now you can see I'll just highlight one particular cell. So how to interpret this 13.82? Okay, in other words, it is 13 rupees and 82 paise. Yes, how to interpret this? How to interpret this 13.816 is it's quite simple. Okay, if we are going to deposit, let's just since we have taken State Bank of India example, if I'm going to deposit 1 rupee at the end of each year for the next 10 years, how much I'll be depositing at the end of each year for the next 10 years if I deposit in State Bank of India? 10 rupees, 10 years, is it not? So how much is the value of that particular 10 rupees after 10 years? Okay. So if I'm going to deposit at the end of each year, remember at the end of each year, not at the beginning of each year. Okay. So if I'm going to deposit at the end of each year, all this particular 1 rupee, for the next 10 years, that is going to be 10 rupees. Total sums of money which have deposited is 10 rupees. How much this is worth at the rate of 7%? At the rate of 7%, this is actually going to be worth 13 rupees and 82 paise. That is how we should be. That is how we should be doing it. Okay. I'll just go to the next sheet now. I'll just go to the next sheet now. So let's see how it can be done with an example. So here I'll just take 1, 2, 3, 4, 5 years. Okay. Next is I'll take cash outflow because we are depositing the money here. In case of banks, we'll be depositing the money, is it not? So how much we'll be depositing? Okay. So how much we are depositing? I'll take some random number. How much I will be depositing? I'm not really sure. So I'll just take some random number here out here. Okay, so this is what is the money which I'll be investing at the end of each year for the next 5 years. Okay, this is what is. So future value. Okay, since we have taken 4%, assume that 4% is the rate of interest which we'll be getting. I'm just fixing this cell. Otherwise, it will be floating. So I'll just paste special, go to, and I'll be fixing it up. So how to do this is I'll just go for 1, that is 1 plus 0.04. This no 1 plus r raised to 1. Okay, so I just put it here. I want to do it for 3 decimal places, as you know. So how much is the total of this? So total will be how much? So I'll multiply cash outflows with the future value interest factor. So I keep getting this particular answer now. Okay, so I'll just sum it up. Okay, we got this answer. So I'll just see how much is I have deposited in fact. So I have deposited 47 lakhs and 35,000. Okay, so 47 lakhs and 35,000 is the amount which I have deposited. Okay, so at the rate of 4%, how much is the total value, that is 47 lakhs and 35,000 at the end of 5th year? How much this particular value will be is 52,000 and 52 lakhs and 70,000 rupees. Okay. So this is what is a capital appreciation you can expect at the end of 5th year if you are going to invest these sums of money at the end of each year. Okay, what happens if you are going to be investing at the beginning? Again, there is going to be formula for that. Okay, so that we will see. What if instead of this, assume that in the previous example we have taken 10,000 for our understanding. So what if 10,000 will be depositing instead of this money? We are depositing 10,000. So 10,000 each. You can see how much this particular 10,000 is going to be growing. So 50,000 will be the 50,000 will be total money which we have invested. This 50,000 is worth 56,000 at the end of 5th year. Okay, since the cash flows are actually going to be same, we can make use of annuity table here. Okay, so how to do this is I'll be taking this 10,000 multiplied by 4% and 5 years. Okay, I'll just go to 4% and 5 years. Where is it? I'll just choose this particular factor value and I press enter. You can see the same answer we are getting. So there is some difference in the answer we can see here. Why is this particular difference is coming out here? Have we taken the right value? We should be checking it actually. At the end of each year we have did it. Yes. Future value, it is correct. So which it is 4% for 5 years, the value we should be taking it. So 4% and 5 years value is 5.416. 5.416. 5.416 is the factor value we are getting it from the table. So what mistake we did? Any mistake we did? 1 plus r raised to n, that is 1. So
Reference is wrong.
let me see. Thank you. I'll just sum it up whether I'm getting 5.416. I can see just here. No, this is something different. It is I'm getting it. 4% and 5 years. The future value rate is 4%. NPER is 5 years. EMT is -1. The type is at the end of the period. 5.416. Okay, so I just want to check it with respect to this. Yeah, any reason why we are getting different values? Class? So this is what is the value we are getting it here, and this is the value from the table which we have derived it. Okay, so let me go for future value. Rate is how much? Rate is 4%. I am just putting 4% here. NPER is, let's say, 5 years it is. PMT is -10,000. I am using the direct Excel function it is. So type is at the end of the year. At the end of the year, I'm taking it now. So 54,163 I'm getting it. So somewhere there is a mistake here in the calculation. 1 plus r raised to 1. Let me see why this is, but the correct answer is this one. So the correct answer is this one. So I think what I'm doing here, because it's an Excel sheet, if you just make one particular wrong thing, it is going to be giving you bang answer. Let me see why it has been coming. Let me come back to it. So I'll be sharing the right Excel sheet with you once I'll be sharing this with you. However, the concept remains the same. Okay. However, the concept remains the same. Whatever we have discussed still will be holding true. Okay. So this is with respect to present value interest factor of an annuity. This we have explained. I explained using this particular Excel sheet now. So hope everybody has understood what is this, how this particular table values have come up and all that. So I'm going back to my PPT now. Okay, so we have discussed this particular PPT, that is financial mathematics basics and their Excel implementation. So we are going to the next sheet, that is net present value. We will be discussing net present value and IRR in some time now. So net present value and the present value. Okay, so suppose you are sure of receiving $100 at the end of each year for the next 5 years, assuming that the bank pays 10% interest on a 5 years deposit, then this 10% is the investment's opportunity cost, the alternative benchmark return to which we want to compare the investment. Is it not? So 10% is the rate of interest, which means that is what is the opportunity cost which we'll be getting it. So we can calculate the value of investment by discounting its cash flows using its opportunity cost of discounted. So what we'll do is the same. This is the same question. I'm just taking this to my Excel sheet, whatever the example it is here. I'm just copying it and I'm going to Excel sheet. Hope this is visible on Excel sheet. Okay. Hope it is visible. No? Excel sheet is visible. Okay. So how much is the amount it is? How much is the amount? $100 it is. So how much is N? N is going to be 5. Suppose that you are sure of receiving 100 at the end of each year for the next 5 years. So this is my PMT. So PMT, you know what is PMT? N per. What is N per also you have understood now. N per is number of years, it is N. PMT is the annual annuity. You will be receiving $100 at the end of each year for the next 5 years. Okay, IY. So what is this IY? Interest per year. So interest per year is 10%. Interest per year is 10%. Okay, so if this is the case, how to be doing? You know that this is year 1, 2, 3, 4, and 5. Okay, so cash inflows. I'll be receiving cash. So I'm just putting it as cash inflows. IF stands for cash inflows. How much is this? So 100 rupees I'll be receiving it for the next 5 years. So I should be fixing it in fact. Okay. So next is how much is the present value at the rate of? Present value at the rate of it is 10%. So it is 1 divided by 1.1 raised to 1. So this is what is the answer we got. So how much is the total now? Is 100 multiplied by the factor value. So again it is the sum. So we got this 379. Okay, so this is what it is, and we can also do this using NPV. You know that what is NPV, is it not? So NPV, the rate of interest is 10%, and you can just take out all these particular values. You can select them, and you get 379. Okay. So please understand, NPV is not the same NPV what we discuss in corporate finance or financial management class. Okay, NPV is not the net present value; it is the present value which is happening in different time horizons that you have to be keeping in mind. So, what if instead of 100, it is something else? So, I'm just putting rand between. So, 100 to 1000. If the sums of monies are different, but still this particular NPV is going to give me the answer. This NPV is actually going to be giving me the answer. But this is not the net present value which we have discussed. This is only the present value. It is not the net present value. Because Excel has not understood properly the concept of net present value. Maybe in the coming versions of Excel that can be that maybe in fact get modified by the people who are responsible for it maybe. Okay, so important Excel NPV function is unfortunately misnamed. It is actually misnamed. It actually computes the present value and not the net present value, that you have to be keeping in mind. So difference between Excel's PV and NPV functions is supposed to be something different. Okay, so we will see what is the difference between this. I'm just copying this. I'll be just copying this example which is out here. I'll go to Excel sheet. I'll open up one more Excel sheet. Suppose that the cash outflow on a project is 250 million. Okay, so you know that what is the cash outflow it is now. So I'll just put it here. So cash outflow, which is given in the problem as 250 millions. So how much is the cash inflows here given in the problem? I just go here and copy this because I can copy quite easily in the PPT rather than anything else. So I'm just putting up here. So I'll restrict this to 11. So this is what is the cash. Okay. Sorry. So we got this. So these are the cash inflows. Okay. What is this problem? Try to understand first of all. Suppose that cash outflow of the project. So this is the project details which has been given. So $250 million is the cash outflow of the project at t is equal to 0. That is today they are investing $250 million. Okay, and the projected cash inflows at the end of each year is as follows. So since they are making $250 million as an investment today. Okay, so how much is the cash inflow which is going to be happening? So cash inflow, they have given it in terms of $1 million. That is what I have taken it here on an Excel sheet now. So I just copied this information. I just copied here. So we know that they also told me that we have to compute the NPV of the project. That is what we have to be doing it. And assuming the cost of capital is 12%. So the cost of capital is 12%. We should be calculating NPV of the project. You know how to calculate NPV, isn't it? So we go for the PV. At the rate of 12%, we compute that impact. So we go to 1 divided by 1.12 raised to 1 raised to 1. I'll be doing it. Yeah. This I'll be multiplying these cash future inflows with the present value factor. Next, I'll be summing it up. Okay, so what is this actually? What is this? We have got $374 million. We got it. This is actually called as present value of cash inflows. This is the present value of cash inflows. Okay. How much is the present value of cash outflow? Present value of cash outflow is $250 million. So I'll just put it here. Present value of cash outflows. I'll be just putting it here. So what is NPV? You know that is the difference between present value of cash inflows and the present value of cash outflows. So I'll be deducting this 250 from 374 minus 250. Okay, so you know that this is actually positive figure now. This is actually a positive figure. So since this is a positive figure, what are we concluding? So we normally can say it as NPV is positive. So we accept the project proposal. Is it? That is what we normally say, is it not? Okay. So, but if I use direct function of NPV, so direct NPV function I'm using, I'm just going to this fx function, and you can see what is that NPV argument is asking me. So rate of interest is asking, the rate of interest is 12%. I'm putting it here. What is the value? So instead of putting one value, I'm just putting all of this. I'm just selecting this. Okay. And I'm pressing enter. You can see what we did. So NPV is not really giving us the right answer. Hope you have understood there is some difference, because the answer should have been 124.785 million. Okay. So, but we are not getting that. particular answer. Isn't it? We are getting 374 million, which is very wrong. So how to do this using NPV function is go to NPV, put 12% as a cost of capital, put comma, and then select this cash range of cash inflows, close the brackets, and you know what is NPV? That is minus $250 million. Next, enter it. You get some answer. So you got this in percentage terms, and you can just convert it into number. Okay. Okay. You can see this and this are matching now. So this and this are matching, which means that NPV is actually, we are getting the right NPV. So we have to be making this particular alteration, okay, for NPV function, which we get it in the Microsoft Excel. And if we do this, we are going to be getting this right answer. Hope it is clear with respect to everybody else with respect to NPV. Since you have understood NPV, what I'll do is, if I want to compute IRR, let's say if I want to compute with the same example IRR, so how it is supposed to be done, I'll just show you this. Okay. Okay. So I'll take this same example. And I just paste it elsewhere. Sorry, I'll just copy this. I go down and I paste somewhere. For example, I want to compute the IRR. So in case of IRR, we won't require all this information. Sorry. So I'll just put 12 here. Okay, so this is 12%. I just put here 12%. Okay, so 1 divided by 1 plus 12% raised to 1. Yes. So we have taken up this. What is actually IRR? You tell me. IRR is that particular discount rate which makes your cash inflows exactly equal to cash outflows, wherein your NPV is exactly 0. That is what is the definition or meaning of IRR. So instead of you getting some positive or negative value in what is it we are going to get in case of NPV, in case of IRR we get a direct percentage number itself. Okay, so that particular direct number itself we are going to be getting it. So how to do it, we will see it. Okay, so I'll just start from the beginning so that there is no confusion. Okay, so this is what is the problem. How much is the cash outflow? I'll write it here. Cash outflow. So cash outflow is given in the problem as $250 million. Just a second, I just take water. Okay. In case of we got cash outflow as $250 million. Now what we do is since we have to be calculating IRR. If I ask you how much is the IRR of this particular project, your answer is, sir, we don't know what is the percentage. But I am expecting that this particular project must be having 20% as the IRR. I'm telling you again, this is only my assumption. I'm just going with my assumption. In case of IRR, you does the same, is it? So what I do is I'll take up the present value factors at 20%. So 1 plus 20 raised to 1 I did. Okay. So then I copy this for all this else. So this is what is my present value at the rate of 20%. So I will total it up now. So how to total it? 95 multiplied by 0.833 and so on. Is it? Then as I just sum this up now, I got it as 220. What is this? Present value of cash inflows. This is the present value of cash inflows. How much is the present value of cash outflows? Present value of cash outflows are how much? Yeah, so present value of cash outflows, as you know, this is going to be present value of cash outflow. I just copy this from here, 250. Okay, so what I should be doing now? So 220 minus 250. If I do, I get what is this? NPV, is it not? Because why this is NPV? So present value of cash inflows minus present value of cash outflows. Okay, we get NPV. That is what we have learned in case of NPV, is it not? Now, so you may ask me a question: why is it you're again calculating NPV? We are supposed to be doing IRR. So please hold on. So please place this cursor, this particular cursor on this minus 29.04. What should be your target? We want this particular NPV exactly 0. Okay, so we want this particular NPV exactly 0, so that at that particular discount rate, we call that particular discount rate is our IRR. In other words, I can say that this 20% what you are seeing is an IRR, is actually IRR we want to get it there. We should be getting IRR out there. That is what is our goal now. So what I'll do is I'll go for goal seek. I go to data, and then I go for what if analysis, and I go for goal seek. Okay, I press on this particular goal seek now. So once I press on this particular goal seek, automatically you can see cell number D30. Cell number D30 means minus 29.04 automatically selected here. D30 has been selected. So we want to set this particular value to what value? We want to set this particular value to 0. By changing the cell, we want this particular cell supposed to be get changed now. So that particular change cell is this 20%. So I press OK. You can see the number of iteration which IRR this particular Excel function is going to take it up. Okay, you can see what has been happening. So minus 9% it is. So what we got is actually a wrong answer. Okay, so minus 9% is the answer we got it. That is what is the IRR answer. So let me try with some other percentage. Normally it gives us the right answer. Okay, not by just 12% or 13%. I just changed the percentage. Okay, so let me do this. Okay, so this percentage I have not fixed it up. That is why there is a mistake. So this 13% is constant. So I just put F4 here. Okay, referencing is the wrong thing which I did it here. Now it is correct. Okay, what I'll do, this is what is the IRR cell. This 13% is there, no? That is where we have to be getting the IRR there. What I do here is, this is what is IRR. So 13% IRR should come there in fact. So what I do, again go for data. I made a mistake there. So goal seek. So I want to change this D30 cell to 0 by changing the cell 13%. So I press OK now. I got some answer. Okay, so I press it OK. Okay, so then I will go to home and then I'll check how much is the rate of percentage. So 29.64% is your IRR. This is how we should be computing IRR. Okay, so you may ask me, sir, this is actually quite elaborated answer. Can we get IRR which is actually going to be quite what I can say is very easy answer we should be getting it. Yes, we can do that as well. So what I do is I just so at 0 how much is happening? 250 million cash is happening. I'm just rewriting this particular problem. Don't confuse yourself. This is the same problem again. It is the same problem. Okay. So the only thing is I am just adding 0. I am prefixing 0 here. And what is the value of this 0 is 250 million. Okay. Then I go here is equal to IRR direct function, Excel direct function. I just select this and I hit enter. So how I got this is a formula text. So 30%. So I can just go and change this 29.64%. You can just see how much is the value out here. Both are matching. Okay, this is how we should be doing IRR. Hope it is clear with respect to everybody else what we are doing it. What I'll do is I'll stop here for a while. Any questions are there, I'll take it. Otherwise, if there are no questions, I can carry out my my class for the next 25, 30, 20 minutes if you wish to. Over to Dr. Prasanna ji.
So thank you so much, sir. This was quite a educative session. I think with a little bit of practice, most of our students should be able to benefit from this. It was nice and educative. I would now request our director, Dr. B.R. Venkatesh, to come in. But before that, just before I request him to join, is there any questions, ladies and gentlemen? Anybody has any questions or doubts that you have, that arise in your mind? I kindly ask Dr. Chetan now. Anyone? Yeah, any questions? Anyone? Students, even faculty, anyone? All right. So I take it that it will take some time to digest. It was quite a heavy dose of mathematics, not really
Financial mathematics.
Generic, not really financial mathematics. So generally not very, what you call, not a generic kind of knowledge where questions can come immediately to mind. But I'm sure with some bit of practice, students will benefit from this. Also the faculty members. So over to you, sir. Dr. Venkatesh, sir. Over to you for your concluding remarks, please.
Okay, fine. Very good morning, Dr. Chetan, Dr. Prasanna, and all my dear colleagues and students. Am I audible?
Yes, sir. Audible.
Yeah. Thank you very much, Dr. Chetan. In fact, I was just remembering my days of my pursuing MBA from JNTU Hyderabad way back in 1988. In fact, during those days, we were definitely not using these Excels, but we had the printed PV tables, FV tables, and all that. First of all, foremost, I would like to really congratulate and thank Dr. Chetan, because he didn't waste probably even 30 seconds the moment he was introduced by Professor Colonel Prasanna. He straight away got into the swimming pool. That is getting into present value table creation. It was wonderful. In fact, I should thank additionally, the reason being, in fact, we have planned to get all our students trained on Microsoft Office, especially on MS Excel. So now, probably today is your lecture on application of our MS Excel for creating our PV tables and other financial tables. Definitely must encourage all our students to become very proficient with respect to MS Excel. I hope I am making a point to all my dear students. May I hear from my students, please?
I request Prasanna ji to any feedback, because finance students definitely they must have understood. At least I can say 80% of the students must have understood what I did. So I request Prasanna ji to take some 2-3 students what they want to say regarding their understanding, because I'm not sure whether they've learned. It's only just one way it is. That is
Dr. Chetan, let me tell you, being a non-finance student, both Colonel Prasanna and myself, we strongly feel that we definitely understood certain very important things. May not be 100%, but certainly 75 to 80% of what you taught. So I'm sure our students would have definitely understood. Probably only thing is, like the current generation, as usual, they do not speak up very immediately after the presentation. Probably that could be the only factor.
Yes.
Otherwise, it was a wonderful presentation. Thank you very much, Dr. Chetan. And hopefully, after the COVID pandemic is over, and when you come down to Bangalore,
Yes,
we would really love to have you at our institution, and maybe for an interactive session with the faculty and the students. Thank you very much, sir, and have a great time. Thank you very much.
Thank you, Dr. Venkatesh, for your kind words.
Thank you, sir.
Right. Before we take leave, I would request all the participants to kindly give a feedback. The link has been shared in our chat box. Make use of this. Click on the link and fill your form. and you will be given the certificate at the end of after filling the form and submitting it. All right. So thank you, Dr. Chetan, once again, and we look forward to meeting you sometime in your next trip to Bangalore, next trip to Karnataka, since you belong to this place. Maybe we have a greater chance of seeing you sometime here. So all the very best in life, and take care. All the students, thank you for joining, and bye-bye. Have a great day. Take care.
Thank you, sir. Bye-bye.
Please do give the feedback without fail.